The 710 series hyperspectral imagers utilize an internal scanning system which provides a versatile imaging spectroscopy solution for researchers. An external C-mount lens configuration allows the lens to be changed between applications or go from a tripod to a microscope as shown here. The internal scanner eliminates the need for cumbersome external scanning hardware and allows it to be used for microscopy easily. Illumination is critical in hyperspectral imaging, and Surface Optics recommends the use of broadband, spatially uniform, diffuse lighting. Ensure that the illumination is uniform across the area to be imaged. Though white panels are commonly used, Surface Optics prefers the use of matched reference panels for improved dynamic range, like the 18% reflectance panel shown here, because most natural materials exhibit similar reflectance. Here we'll be using a veneer hyperspectral imaging to identify bruising in apples and walking through the steps in the process. Setting up the image capture is straightforward. Focus on your scene and adjust the integration time to increase signal. There are other more advanced settings as well and can be used as needed. The 710 series utilizes both a focus camera and a scanning camera. Before collection, the focus camera is moved in front of the lens to set focus, ensuring that the scanned image is also in focus. The time it takes to scan depends on the integration time, but can be from a few seconds to on the order of minutes. The spectral plot is a useful tool for the quick assessment of points of interest in the scan scene as data is being collected. However, since the illumination spectra is present in the raw count data, the spectra shown may or may not be of use. The green apples shown are the same variety and were purchased roughly 2 weeks before the experiment. It is clear visually that there is bruising, but from the spectral plot at this point, it is not easy to see if there is distinguishing spectral features for the bruised areas. The next processing and analysis steps are commonly done in Envy, MATLAB, or some other custom software. Surface Optics provides a toolkit for analysis that will be used here. Spectral bands can be selected, and other processing steps can be performed. First, we will calibrate out the illumination spectra and convert from counts to reflectance. An area on the reflectance panel with identical illumination to the scene is selected. The spectra is saved. Then it is read back in to set as the light reference. Now, the spectra is showing reflectance instead of counts. To identify bruising, we will apply match filters by selecting areas on the image. The first area is clear visibly as a bruise on the middle green apple. Applying a match filter overlaid on the image shows other areas on both green apples that can be visually confirmed as bruises. It can also be seen that an area on the red apple has the same spectra of the bruises on the green apples. The next area is the unbruised green apple. The unbruised green apple spectra is now shown. Next, the red apple. The spectra of the selected area can be saved for further analysis as well by writing it to a file. Applying the red filter. In the end, the bruise areas on the green apples were easily identified spectrally. But this experiment also shows why attempting to classify bruises across multiple apple varieties may result in errors, as an unbruised section of the red apple has an identical spectral signature to bruised sections on the green apples. The 710 series are excellent for field use as well. Here, the 710 SWIR imager was used in an environmental project looking at the impact of plastic refuse in a watershed system. A large metal calibration panel was used to ensure a stable reference was available, as Surface Optics typically provides paper calibration panels. The 710 series can be run on a tablet using battery pack power as well.